So today we are going to study how to solve linear first order differential equation. So we are gonna focus on this type of equation plus px yx is qx plus y0 is a number a. So how do we solve this? So the step one is compute the integrating form, which is exponential integral px dx, like this. So the second step is multiply by this integrating form on the star. This is exponential map px dx multiplied by yx plus exponential map px dx and px. We add a bracket here. This is yx. This is equal to qx exponential map px dx. And then you will realize what's this. So this is the exponential map px dx. This is the derivative of this term. So we got this should be exponential map px dx multiplied by yx. So by the product rule, the derivative of this term is the left term, this. Okay, this is qx exponential map px dx. And then we can get yx multiplied by exponential map px dx is the integral qx exponential map px dx. And then we can get yx is exponential negative px dx plus qx, no, not plus, multiplied by this exponential map px dx and then dx. So after you got a yx, there should be a constant. You know, you cannot, because if you look at the integral of px, there should be a constant. Means that the left hand is undetermined. So the step 3 is plugging y0 is a, and then you fix the right hand side, and then you fix the right term. So let's look at one example. This example is from the worksheet. Problem 1, for example. So this problem is y derivative x is a plus 3y is 5e2x. y0 is 3. So first we know px is 3 and qx is 5e2t, no, x. So and then step 1, compute the exponential map 3 dx. So this should be e3x. I think it's right. Okay, this step 2, multiply by this on the both sides e3x y derivative plus e3x multiplied by 3 and yx is 5e5x. So we know by the computation on the left hand side, we know this is yx e3x derivative. This is 5e5x. And then we know 5 yx e3x is the integral 5e5x dx, right? Or you can add c because c is already included in this part, so you don't have to add c here. So we get a 5 yx e3x is e5x plus c, and then yx is e3x e5x plus c. Like I said, there is a c on the right hand side. Okay, and then we have the step 3. So step 3 is plug in the value y0 is 3. So we get 3 is y0 is e0 e0 plus c. So we got c is 3. Hence, we have yx is e3x e5x plus 3. I think this is 3. Sometimes the pencil has some problem. So we get this is e2x plus 3e3x. Therefore, the solution of this equation is yx equals to e2x plus, oh, sorry, I think I made a mistake here. So let's erase it. So this is 3 equals to 1 plus 3. This is, so we got 2, c is 2, and then we have yx is e3x e5x plus 2, and then yx is e2x plus 2 times 3x. This is the final answer for this equation. Okay, so if you look at the left hand side, you can say it's very complicated, but if you look at the right hand side, you know, it's quite simple because every step you get the answer. You just follow the left hand side and continue to compute it. You will get the answer. But one thing is important is you have to know why we do the step 1. That's because after we got the integration form, the left hand term, for the left hand term, you can always use the product rule and convert the complicated stuff into a derivative of one term, and then you can integrate them directly, and then you get the yx. After you got the yx, you have a constant which is undetermined, but you have one more information is about y0 is a number, right? You can set x is 0, and you can finally determine the c. So that's why for the final yx, you don't have a constant, or you can say the constant is fixed. Okay, so I will stop. Please do the worksheet. I'm okay.